Hello physical science students, welcome to another video. This time the structure of ionic solids. Ionic compounds form crystals. We've seen a couple of pictures of those already. What is a crystal? A crystal is simply a three-dimensional array of positive metal ions and negative non-metal ions. And that three-dimensional array is referred to as an ionic network lattice, and it's held together by the electrostatic attraction between the oppositely charged ions, which we mentioned before. The ions themselves are arranged in a regular repeating pattern. That's why it's called a lattice. It's a regular repeating pattern throughout the crystals, and each cation is thus surrounded by anions, and each anion is surrounded by cations, and we'll see a couple of pictures of these shortly. The relative numbers of cations and anions are fixed by the requirement that the structure is neutral. So when we're writing our ionic formulas, the reason we're balancing the charges is because that's an expression of the fact that the solids themselves are neutral. The positives balance the negatives. The relative sizes and number of ions present determine the actual lattice structure, and there's a whole myriad of different types of lattice structures. Models to show ionic solids. So these are a couple of examples. So this is a small section of what a sodium chloride crystal or salt crystal would look like, where you have the larger chloride ions and the smaller sodium ions stacked together in a regular arrangement. Doesn't look like it so there. That's because we also might use this method where we show the structure. In this case it's a cubic structure, and if you looked at one of these green spheres, the chloride ions, it's got a 1, 2, 3, 4 and 5, 6. It's got 6 sodium ions around it, and the same goes for the sodium ions. They've got 6 chloride ions around it, and so it's held together by the attraction, but there's also an interplay of opposition. Now these models are called space filling model and the ball and stick model, and they're supposed to be representations of what it actually looks like, where these spheres represent the zones of where the electrons would be occurring. The nucleus of course would be in the center of that. Here's some more models. These are all of sodium chloride, which occurs, if you look very small at very well developed salt crystals, are cubic in shape, and there's numerous ways of representing it, and these are all other ionic solids as well, with different lattice structures. And so these little sections here are repeated over and over and over and over and over again, so you get something like this, which is a little plastic model of a ionic lattice. And you can also have one like this, where it's got a different structure, different shape and different structure. And there's another one. Someone spent a lot of time in computer graphics making that one. So the next video we will be looking at the properties of ionic compounds.